Hi, everyone. Welcome to another Student Zone session here at Build. We're really excited to have you. As a quick reminder, this is our Microsoft Code of Conduct. If you've seen any other sessions here at Build, you're probably familiar. Basically, let's be kind, let's be friends. We're all here to find community and a friendly one at that. So let's keep it to that. I'm Sarah. My name is Sarah Guthels, and there's been a quick change of plans, and I'll actually be delivering this talk today, but I'm really excited to be here. My background is in computer science education. That's what I got my PhD in, and I've had the pleasure for the last year and a half to work with this NASA team to build what we're presenting to you today. So we launched it last year at a conference, and I want to re-bring it up to you today because we're still committed to building materials for students, for parents, for teachers, and I'm just absolutely thrilled to be talking to you a little bit about how astronauts study images. So without further ado, let's get started. We're going to talk a little bit about the ISS crew, that's the International Space Station crew, and how they manage imagery. We're going to talk a little bit about Earth science and remote sensing, go into machine learning with crew images, and then I want to show you this Microsoft Hacking STEM lesson that I mentioned that I worked with this NASA team on, where we walk through some natural sciences, some earth sciences, and machine learning all in one. It's going to be awesome. So first of all, this is a real ISS astronaut. This is a real astronaut on the ISS, rather. So this is an astronaut who is taking images of our Earth from the International Space Station. And one thing to note about this is they take images for a lot of reasons, but oftentimes their images, though absolutely stunning and beautiful, come out like this, where we might have some things kind of in the way. You can see part of the International Space Station here. And again, we're kind of got this really high level, absolutely gorgeous view, but high level view of the Earth, which makes it sometimes difficult for us to identify exactly what we're looking at as humans. A few reasons that the astronauts on the International Space Station take pictures is for what's called Earth science and remote sensing. And basically, the mission of this unit is to become, and I'll read this on the screen and then I'll explain it, to become a recognized center for terrestrial remote sensing from the ISS and focus for regional remote sensing and some more in support of climate adaptation science. And basically what that means is by being able to take images and readings and do some basic machine learning on the images that these folks are taking, we're able to start to track and identify different regions around the Earth and how their precipitation, their temperature, and then the general kind of effect of the changes of precipitation and temperature and humidity and things like that affect the Earth around us. And so the goal of this is to collect images, to analyze them, and to really explore how our Earth is changing, understand it, and be able to hopefully predict things so that we can make a better impact rather than a worse one. Now, a lot of the pictures that we take, as we saw kind of in that earlier picture, look a little bit like this, right? They're very high level. We might, with super zoom and clear skies, we might get some features. And Feature Hunter was developed by NASA for college and high school students. And what this does is basically allows us to identify features in images such as rivers, lakes, agricultural plots, and that helps us to gain more information about what we're seeing. Because if you look at, for example, the picture of the island, that looks very similar to the picture of the lake, where there's kind of this roundish outline of something, but the lake is more that, darker color where the water is, whereas the island is more of a greener color where the land is. And so being able to identify the features of an image helps us identify what we're looking at. So when we analyze the images, we know what we're analyzing. We know the kind of answers we're trying to get. And with that, I want to tell you a little bit about this project that we developed with NASA. So if you haven't heard of Hacking STEM, I highly recommend searching it and heading over to Hacking STEM. We'll place a chat a link in the chat window. But Hacking STEM basically creates educator resources that are essentially free. And I say essentially free because sometimes we might use things like paper and simple cardboard and tape and things like that. So we try to keep all of the lessons at a very low cost to teachers and parents and students. And last year we launched this NASA collection, which is a series of 8 lessons that we developed in partnership with NASA to talk a little bit about science and STEM from the perspective of NASA and their astronauts. So for example, there was a lesson on designing astro socks because astronauts need socks to keep their feet warm, but we don't want any static electricity being generated from those socks while they're on the ISS. That's a really, really important feature of socks that astronauts wear. So this lesson talks a little bit about that. It talks about the socks. It talks about the purpose of them for astronauts specifically, not just for humans on Earth. And then it talks a little bit about that electricity. The lesson I want to tell you about today is the analyzing the astronaut's photo of Earth to predict climate change. And like I mentioned, there's a small cost here, and this is really the cost of Excel. I just essentially downloaded Excel, and everything else was basically included there. So there's a lesson here. You can see it's predominantly targeted towards middle and high school students. And if you aren't a teacher, if you're a parent, or if you are a student, you can still check this out. There's nothing blocking you from it. It's all free and publicly available. There's also this really amazing video that NASA produced kind of talking about what we're about to go through today. So I already downloaded this Excel workbook, and I want to walk you through it a little bit because this is how NASA starts to understand the Earth that we live on. So this is just Excel. When I first saw an Excel workbook like this, to say I was shocked is an understatement. I mean, this looks like a website. This looks gorgeous. This is literally Excel with some macros on it. So it's pretty awesome. Basically, when you do download this Excel doc, you'll need to make sure you enable content. And when you do so, you can actually interact with it. So to start out this lesson, because we're talking about images, really what we're talking about in images is what we can identify in them. And maybe we can use something like Feature Hunter to help identify the features of an image. But I don't know about you, when I'm looking at a big image of the Earth from a really high level up, I see colors, right? And I think that's a lot of what we associate with those images from space, right? The blues and the greens and the whites and the browns and all of those colors. And so this lesson is really talking about the colors of images and how we can use colors to identify what we're seeing and potentially track some changes in our Earth. So to get started, because we're going to be analyzing these images with machine learning, aka a computer, we need to learn how computers identify colors. And this sheet right here is a really, really great way to start to learn a little bit about RGB values, hexadecimal values, and basically crayon colors, which is how I identify colors. I don't know about you, but if I think of a color, I'm thinking of like Tickle Me Pink, right? It's a crayon color. So what we have here is we can change the red, green, and blue values here in the Excel doc, and that'll show up over here on this kind of output area. And this output will show our RGB color as well as our crayon color. Oh, and it looks like we've got a little puppy here. Welcome to my home, everyone. So what we have here is, for example, you can see that this is all red and all green and no blue, and that creates yellow. So colors are from 0 to 255 in value. So for example, if we change this to 0, oops, if we change this to 0, and we change this to 0, and we change this to 255, we would get blue. We can also check out some of the hexadecimal colors over here. So this really pretty purple right here, that's called vivid violet. That's the nearest color in crayon speak. And the RGB values are 128, 55, and 144. We can also see the hexadecimal versions of those values here. So we have a bunch of lesson plans around how to talk about the difference between decimal, hexadecimal, and then the crayon colors. And so I highly encourage you to check those out. But this is just a really great introduction into RGB, hexadecimal, and crayon colors and how computers identify colors. This leads us into, now colors is one thing, but colors also are associated with what we're looking at on the Earth. And one way of identifying what we're looking at is by using biomes. So we have 7 biomes over here: the grassland, temperate forest, tundra, etc. And each of these biomes have different features. So for example, the desert, it's really hard to see here. I can try to zoom in a little bit. We can see that the desert is outlined in this really light white outline right here. And again, I encourage you to play around with this a bit on your own. And so we can see where the desert is outlined on this Earth. We can also take a look at a temperature map. So this is a temperature map, and we can see again that that white outline that we identified earlier as the desert is a lot darker red than, say, up here, where it's really kind of white or a really light pink. And we can also look at a precipitation map. So again, we can see that where that desert was, there's pretty much no precipitation, and in other areas there is. And so this sheet basically allows us to start to understand what we're looking at when we're looking at the Earth, right? So each biome has different features. A savanna might have, quite a bit of precipitation and not too hot, versus the temperate forest, it looks like it's also not too hot. And in terms of precipitation, it's a little varied, but not super rainy. Tundras, those over here, don't have a lot of rain, but are very, very, very cold, right? It's closer to the 0 degrees Celsius. So we can start to understand these features of these different biomes. And what that allows us to do is then apply basically math and machine learning to be able to identify whether or not an image is coming from one of those biomes. So let's figure out how to do that. We can also see, for example, that a savanna has temperatures of pretty much about 22 to 23 degrees Celsius, and precipitation in millimeters at, it looks like it varies. And one thing that we can do here is we can actually grab this and head over into insert recommended charts. And let's just choose this chart right here. So this is our average temperature for a savanna, right? And we can see that it does do this, a little bit of this drop right here in July. And we can take a look at the precipitation similarly, just like this. And we can see that similarly in July, there's that drop in precipitation. So there's kind of like this similar structure to the temperature and precipitation here. And we can start to have a conversation about that and explore it. And, we cheated a little bit. Well, it's not cheating, but we want to kind of bring you along on our journey. So we do have all of these graphs already made for you. So we can see a tundra stays relatively cold the entire year and has a pretty consistent precipitation rate. The boreal forest has this nice little cyclical temperature and, again, a relatively persistent precipitation rate. And we can check out all of these different biomes here. We can compare the biomes and have a conversation about this. So tropical forests kind of look like this, whereas boreal forests kind of look like this. And we can also start to identify a color feature of these biomes. So these are images taken from these biomes at different times of the year. And we can see, for example, that the grasslands are pretty brown in October and December. They're pretty green in July through September. And then it's kind of got these mixtures over in January through June. We can compare that to the boreal forest, the tundra, the desert. And this is where we can start to identify what we're seeing. And we can start to track the changes that are happening as a result of what we're seeing. So if this is our known kind of color wheel of our grassland and our temperate forest and our boreal forest and all of our biomes, then if we identify an image during one of these months that might be off on this, and we see that over time, we can start to identify changes in our climate. So what does that actually mean for AI and machine learning? Well, we've designed this machine learning simulation, if you will. There's actually machine learning behind it. And I think I hear a little toddler in the background who might want to help me out here because I think my eyes aren't good. I'm wearing glasses. I don't know. Is there a toddler around here who might want to help me pick out some pictures and colors? Hi! The joys of working at home. We've got a little toddler here. This is Ayla. Look at these pictures. So we've got some pictures here. And what our goal is given these pictures and knowing where we're, knowing a little bit about the location of the picture. So for example, this is our monthly temperature and precipitation. Do you think you can help me pick out a picture? Which one should we try to guess? I like this one. This one right here. Look at that one. This one's a picture. We don't know where it's from. And this looks like it's coming from a monthly temperature of about 22 degrees Celsius. And it looks like it's coming with precipitation of 100 centimeters. It looks like you don't want to help me pick out pictures. That's okay. Maybe we'll learn about NASA later. Sound good? Toddlers don't want to make cameos today. That's okay. I need more. So what we can do here is we can start to identify the different pictures, and we can start to try to guess what we're looking at. And the purpose of this is to identify the difference between what a machine can see and what a human can see, and why it's important that machines are part of this journey. So for example, I'm going to pick this picture, and I don't know what this is from. I don't know what biome this is from. And so as a human, as maybe an astronaut on the ISS, I might snap this picture and I might know where I am I might be able to have some sensors for what the temperature is and what the precipitation is, but I might not know exactly what this is because I'm, really high up in space. And things might be changing over the years. And so I don't know what kind of changes are happening. So we can go in here and I can try to pick out a color. This is going to be, what is the most prominent color of this picture? This is really hard for me as a human. It looks like it's a little bit brown, so I'm going to kind of go into these. It's like a greenish brown. Like one of these kind of colors looks about right. I have no clue. This is why for humans this is hard. Now a computer, we saw how computers recognize colors with those RGB and hex values, right? And so a computer can take this image and go through all the pixels and kind of identify that. I'm not super great at that. This is my best guess though. So I know that this picture is coming from 22 degrees Celsius and 102, and I think that's actually millimeters in precipitation. And so if that's where that's coming from, 22.9 and 102. So I'm going to take a look at, these are just the graphs that we saw over in our Excel doc. So we saw these graphs over here. So this is not about the image, but rather this is about the different biomes, right? So what I'm doing here is I'm trying to gather as much information given an image and a couple of data points about where this image is coming from. So if I take a look at one of these biomes, 22.9 and 109, I mean, 22.9, it looks like maybe somewhere around here. I mean, that's 35. So I'm going to say it's pretty warm, but then 109, if I'm taking a look at all these, I'm going to say that might be a savanna, because if I kind of look at these averages, it looks like that might be close to 109 there. So I'm going to guess that this image, given those data points, is a savanna. Now, this is the color that I thought was most prominent. And again, looking at the comparisons of the colors for each of the biomes, I can take a look at what month do I think this image is coming from. It kind of looks like March to me. So I think that this is an image of the savanna in March. Now, we ran this image through a machine learning algorithm, and we're going to analyze what the machine said compared to what I said. Hey, I got Savannah right. It looks like this is from the Savannah, but it's actually in December. So this middle image here shows the correct identification. This is the Savannah. It's from December, and the color is this hexadecimal color. I estimated that it was the Savannah with this hexadecimal color in March, and the machine learning algorithm estimated that it was Savannah with this hexadecimal color. So you can see it was a slightly off in December. Now, what you could imagine is if we had a bunch of images, like thousands and thousands of images, and we were trying to track changes over time, it looks like the machine learning algorithm is more accurate than we are. And that's likely because it's more accurate at picking the color out of this image. Because to be honest, I don't know how many times I could do this. Just trying to identify this color here is just a near impossible task, in my opinion. So if we can use machines to help us with the parts that machines are good at, aka colors in images, then we can get better estimations of what we're looking at, and we can better predict what's happening to our Earth as we kind of track it over the course of years. And so that's really what this lesson in particular is about. I want to remind you that Hacking STEM has a number of lessons on NASA topics. We mentioned the astrosocks, we've got determining heat resistance, we've got alpha, beta, and gamma radiation. There's a lot here to take a look at. And I highly encourage you to check out all of the different lessons that we've built with NASA and keep coming back for more. Justin, do we have any questions from anyone?
Hi, Sarah. So I think we are mostly caught up on questions, but I think one of the biggest ones that I saw that was popular is what are scientists and computer scientists doing today with AI to help predict global climate change?
That's a great question. In fact, Justin's going to be doing a talk about that a little bit later in the student zone about how we're using AI to help predict climate change using polar bears. So I highly encourage you to check that out. But in addition to that, it's similar to what we just mentioned today. So this is one example. It looks like a sample for students. It looks like something for us to just learn with, but this is actually how scientists are using AI in the real world to actually predict things like climate change and just pretty much everything about our natural world. So it's really about identifying one specific problem, looking at the data that you have, and then using the right AI or machine learning algorithms to be able to draw conclusions from that. So for example, in this case, what we did was we had images. We had images and we had some data points about precipitation and temperature, and that's all we had, right? And this is actually all the NASA astronauts have. They don't have exactly what biome this is from unless they go and compare coordinates, which is just a very manual kind of behavior. They'd have to kind of track all of that. It's just kind of a lot. So rather than doing that by hand and then also tracking it over years and tracking it, the very, very slight variances by hand, we use AI/machine learning to analyze images, to extract data from them, whether it's those features that we mentioned at the beginning or colors in this example. We use AI and machine learning to extract features from what we have, which is images, and then we ask a particular question. In this case, it's, what is the color and what is the average of those data points, and how can I combine those to determine what month and what biome this image was taken from. So there's a number of ways that AI is being integrated. I mean, I couldn't possibly list all of them, but we do have some additional resources on our GitHub repo, aka.ms/students@build, where I will continue to post more resources, and I highly encourage you to check out Justin's session on polar bears later today.
Yes, thank you, Sarah, for that. Yes, that session is at 10:30 p.m. Pacific time. Be sure to check the build calendar to join that.
So that's as well. Like 13 hours away.
Yeah, it will be available on demand starting May 22nd, as with all sessions as well.
Yeah.
Another great question, since we have a few minutes, Sarah, is what are some popular tools for image and video analytics?
Oh, great question. So one thing that I personally like to use is the Azure Cognitive Services services. This is if you're going to get a little bit more technical. So this is if you're going to write some code and you want to actually analyze all of your images with code. I really enjoy cognitive services because we've got these APIs, for example, on vision, and we've got this computer vision, custom vision, face detection, and let me zoom in on this just a little bit. We even have form recognizer. So this is extracting text from images, ink recognizer. So handwritten text and being able to extract what that text is, and then a video indexer. And so, for example, you mentioned video. And so the video indexer, this site here will kind of give you an overview into it. But basically, given a video, it'll start to identify people. If it's someone, for example, Satya, that we have lots and lots of video and images of, and we know what Satya looks like, it might identify key people. It might listen to what is being said in the video and identify keywords. And this is one way that you could use cognitive services to analyze video. So I personally really enjoy integrating with cognitive services, and there's a lot of documentation here and a lot of getting started guides that you can check out just by heading over to the cognitive services link, which someone will hopefully link to you in the chat.
Very good. I think we have time for maybe one more question. Awesome. Dominique asks, is it possible to predict the size of rainforest by color analysis through the years?
Yes, that's a great question. I don't personally do that as my main job, so I can't like definitively say yes, but I will say yes in the sense of exactly what we were talking about with that feature analysis as well as the color analysis, right? So we can use that feature analysis to identify those lines. We can say, I know that there's a rainforest here. And so then we can constantly take multiple pictures, you know, over the course of years, you know, maybe one every week, one every month. I'm not sure what the cadence would be there. So we can take, you know, hundreds and thousands of images over the courses of years. And if we know that there's a rainforest there, we know where the lines are. We know that those lines are there because of the color differentiation. That can definitely be used. And I want to go as far as to say that when we use color to analyze, again, when it's not the human looking at the color, but rather the computer looking at the color, we'll be able to identify these really subtle differences between maybe the health of the rainforest. So if it's very, very green one year and then maybe like a slight yellower tint the following year, then we might know that there's a potential for that to not be as healthy as it was the previous year. And maybe that could help predict when it might shrink, right? And so we could use color and those features to identify like basically these triggers that might help us predict what might happen in the future and then might help us correct that, if that makes sense. So definitely, I think that's a really, really great example. And one thing that you could do is start doing it in your own yard, right? So maybe if you have a plant, if you have a bush, take the picture from the same place, you know, maybe same-ish time of day for, you know, I don't know, every day for a month or a few months. And then maybe you can try out Azure Cognitive Services and start to see, are there any differences? Can we extract any kind of color differences from these? And can I see the health of my bush? And then maybe you could try watering it more or watering it less or changing up the fertilizer and seeing if that makes any difference. So you can actually try this at home too. And I highly encourage you to take what you're learning here as kind of these really big, you know, world-changing solutions and try them out in your own backyard.
Awesome. So just of note, I will reply to everyone who's asking for beginners resources in just a second. Sarah, we got one more question for you, and I think it's kind of a fun one. Awesome. If we were to try to understand the climate of another planet, would we have to rewrite our algorithms?
That's a really, really great question. You know, I think we would. And I think, again, I'm not the expert here on this. I'm not an expert on Mars, for example, but I think we would. And the reason is kind of the differences in the atmosphere. The difference is in how colors appear and why. I don't necessarily think we would have to rewrite the algorithm, but I think we would have to retrain it. And I think we would have to have a lot of additional data prior to that. I did want to mention again, aka.ms/students@build. And before we head out, I know we've got like 1 minute left, but I'm really excited because Crazy Aunt Lindsay decided to come into my session today and talk to you all. So I'm going to pass it off to her for the last minute.
Hey everyone, what an awesome session, Sarah. Thank you so much. And if you have little students, much like Sarah's little one, then you can head over to youtube.com/thefablabhq, where I have projects inspired by NASA and astronauts that you can do with your little ones right now. Now, what we're going to do over the next 2 hours is give you the opportunity to check out some awesome keynotes. The Future of Tech is going to talk about AI and machine learning. Scott Guthrie is going to do a Q&A, and then of course you can learn about Power Platform. Now make sure you get up. I don't know about you, but I've been sitting for a really long time, even though it's 9:30 a.m. here on the West Coast. Stretch out, nice and big, get some water, grab a snack, and then meet me right back here in the next 3 hours, where you will be able to see a panel with former Microsoft interns that are now full-time employees, a session with Chloe, April, and Misty the robot, and of course, an introduction to genomics. Genomics, excuse me. I'll see you soon.
Awesome. And don't forget to fill out the survey, please.
Yes, the survey, which I think is going to be in the chat box. Make sure you check that out, and we'll see you right back here.